Welcome to Java Data Structures course. In the previous session, we have completed the concepts of binary search, breadth first search, and the collection interfaces and iterators we have already implemented previously. So now we are going to get started with the concepts of inheritance. Now, when it comes to inheritance, we are going to make use of the reference of subclasses documentation from Oracle Java. And here is the documentation for reference for inheritance. The official documentation from Java. Now, so what is the inheritance? Let's have a quick understanding of this. So when it comes to inheritance, you can see the definition states a class that is derived from another class is called a subclass. Okay, so let's say there are two classes, class 1 and class 2, and class 1 is inheriting the properties from class 2. So class 1 will be considered as a subclass, okay, or a child class. So we call these classes as derived class, extended class, or child class. The parent class will be class 2, whose features will be inherited in class 1. Okay. So the class from which the subclass is derived is called a superclass. So let's say the properties of whichever class we are trying to inherit in a subclass, that class will be known as the superclass. Okay. We can also call it as a base class or a parent class. So is that clear? So suppose you have an example here. Suppose we have multiple classes here. Consider this is class 1, which we are trying to program. Now, when we started programming this class, we inherited, let's say, another class known as object in it. Okay. So now the upper class will be known as the base class or a parent class or a super class. Similarly, the second one, these will be known as the subclass, the derived class, or the child class. Okay. This will be known as the subclass, derived class, or the child class. I believe this is clear. Now, how do we do that? We are going to understand it. Now, classes can be derived from classes that are derived from classes that are derived from classes and so on, which means there could be n number of hierarchical structure is possible when it comes to inheritance. It might be possible that you have started writing a class code. Okay. Now that class code might have inherited one class, which in turn has inherited other class, which in turn has inherited other class, and might have inherited one more class. So there could be a complete hierarchy of classes inherited. Is that clear? So that is also possible. So the statement states this. Okay, the statement.
Okay.
Now ultimately derived from the topmost class, and the topmost class is always known as the object class. Okay, such a class is said to be descendant from all the classes in the inheritance chain stretching back to object. So we call this as descendant. Okay. Now,
Yes.
Now we'll continue. So why do we use it, and what is the idea behind inheritance? So it states the idea of inheritance is simple but powerful. When you want to create a new class and there is already a class that includes some of the code that you want, you can derive your new class from the existing class. Okay. So suppose you started writing a program known as, let's say, making a car. Okay. In order to make a car, there are certain fundamental methods which are already available in another class. So instead of rewriting the class, it could be a possibility that you can inherit the properties, okay, of that class. Now, in doing this, what is the benefit? The benefit is you can reuse the fields and methods of the existing class without having to write and debug them yourself. Is that clear?
Yes.
Now, coming to the next part, a subclass inherits all the members. So whenever you implement inheritance, what all will be inherited? suppose the class 1 has a few properties in it. Let's say this is the class 1, and this class 1 will have the fields. Fields can be considered as variables or constants. Okay. So we call them as fields in general. It is a combination of constants and variables defined in that class. Okay. Other than that, there could be methods defined in it. Okay. Only public methods can be accessible. Okay. Private methods are not accessible. Other than public methods, what do we have is you can have the public classes defined within it.
Yes.
Classes can also be accessed. So all of the fields, methods, and public classes can be inherited to the subclass whenever you start inheritance. So all of these fields, methods, and public can be accessible within the derived class. Is that clear?
Yes.
Now, so what do we get? We get fields, methods, and nested classes. Now, constructors are not members, so they are not inherited by the subclasses. So let's say in case if there is a constructor in an object or in the parent class, the constructor will not be inherited within your subclass. Is it clear? Now it states the constructor of the superclass can be invoked from the subclass, which means you can call the constructor, you can initialize that parent class by calling the constructor, but you cannot modify or you cannot override the code of constructor in the subclass. Is that clear?
Yes.
Now, coming to the next point, what is the platform hierarchy? So it states in Java, first we have the object class. Okay. Object class is the descendant class for all the classes, whatever we might be using. So the object class defined in Java defines and implements behavior common to all the classes, including the one that you write. Okay. So irrespective of n number of classes available in Java, all the classes have the descendant as object. Okay. In fact, the new class which you will also be creating, that's descendant will also be object always, the object class. Okay.
Okay.
Now, in the Java platform, many classes derive directly from object. Other classes derive from some of those classes and so on, forming a hierarchy of classes. So depending on the program, you might have a different hierarchy of the classes and the descendants for the program. Okay. At the top of the hierarchy, object is the most general of all classes. So it might be a possibility that the descendant will always be object. That is a very, very high probability, or in general, mostly the object class is the descendant class. Now, so classes near the bottom of the hierarchy provide more specialized behavior. So here we are going to have an example now. Okay. Suppose. So how are we going to perform inheritance? Suppose there is an example. Let's say we have a class known as bicycle. Okay. The bicycle has the following fields: cadence, gear, and speed. Okay. Now you have constructed the bicycle class by providing cadence, speed, and start gear, and you're going to modify the properties. Okay. So it could be something like when you started cycling, what are these three parameters? So they might start from 0. Okay. Now, bicycle has 4 methods which states set the cadence, set gear, apply brakes, and speed up. Okay. These are the 4 common methods available in the bicycle. Now, there could be n number of types of bicycles available. It could be mountain bikes, it could be child bikes, it could be sports bikes. Okay. There might be different varieties of bicycle now available, but all those different varieties will have this in common. Okay. Every class will have cadence, gear, and speed. Every bicycle will have the following. Now, in order to do that, what we can do, So for example, we are creating a mountain bike here, which is a subclass of the bicycle class. So how we are going to do it? We are going to inherit the property by extending the bicycle class in our subclass. Is that clear? So we can call this keyword extends. Using the extends keyword, you can define the name of the parent class, but the property states only one inheritant or the parent class can be inherited into the child class. In order to support multiple inheritance, we need to make use of interfaces. Okay, interfaces will help you multiple inheritance. Is that clear? So we'll see about it. So now, so in the mountain bike, there are some new fields which have been added with states seat height. Now, in order to construct the mountain bike, along with cadence, speed, and gear, it has a new property, start height, which has been defined within the mountain bike only. So this feature might not be available in all the bikes, but in the mountain bikes, the height feature will also be available. Okay. So, and the other facilities like the cadence, start, speed, gear will be working as per the main class which has been inherited into the code. Is that clear?
Okay. Yes.
So there are certain properties. So what can you do in the subclass? We can see here. So the subclass inherits all of the public and protected members of its parent, no matter what package the subclass is in. If the subclass is in the same package as its parent, it also inherits the package private members of the parent. Okay. So suppose we are in the common package. So let's say you have defined a package known as com dot something dot bhavesh, and within that you have defined two classes. Okay, and you inherited class 2 in class 1, and both are in same package. So in that case, the private members of the package will also be accessible. Is that clear? But in case if the classes are in different packages, then private members will not be accessed. Okay.
Okay.
You can use the inherited members, replace them, hide them, supplement them with new members.
Okay.
Now, what next we have? So you can see that the inherited fields can be used directly, just like any other fields. You can declare a field in the subclass with the same name as the one in the superclass, thus hiding it, which means, let's say if you have cadence defined in base class and you are also creating
Yes.
a new variable cadence in the subclass. So the base class variable will be hidden. Its properties
Okay.
will not be accessed. Okay. But it is not recommended. We should use different variables. Coming to the next point, you can declare new fields in the subclass that are not in the superclass. So we can create new fields the way we created seat height. Okay. Now, the inherited methods
Yeah.
can be used directly as they are. So whatever methods, whatever code has been implemented, you can call it directly. Along with that, you can write a new instance method in the subclass that has the same signature as the one in the superclass, thus overwriting it. So what you can do is you can override the methods also. Suppose in the mountain bike, you want to modify start cadence method. So what you can do is you can define the same method, which means let's say start cadence, set cadence. You can define this method and override this method in the subclass. Okay. So the
Okay.
code of
Yes.
base class will not execute. Instead, the code of subclass will execute. Okay.
Yes.
You can write a new static method in the subclass that has the same signature. So with that, the class will be hidden. Then you can declare new methods in the subclass that are not in the superclass. That's possible. You can write a subclass constructor that invokes the constructor of the superclass either implicitly or by using the keyword super. So that can also be done. We can inherit a class and then we can define the constructor for the subclass also. Okay, so that is possible. So that's a quick overview of how inheritance works. Now we're going to take up an example. So let's get it going. So what am I going to do? I'm going to close the previous projects and I'm going to start a new one. So starting a new project known as inheritance, and within this, I'm going to create a class inheritance test. Or let's say I'm going to call it as, this is going to be my class A. Okay. Or what we can do is we can set up certain properties. Let's say, what am I going to do? I'm going to make something, let's say, okay. So let's say I'm making a class known as heart monitor. Okay. There's a class known as heart monitor. Let's say. Okay. So this is going to be a class heart monitor. This I'm going to make this class as a parent class. Okay. Treat this class as a parent class. Okay. Now within this, I'm going to define a method public static void main string arguments. Okay. So suppose you have got a main string, a class known as heart monitor. Now within this heart monitor class, what am I going to do? Let's say I've got something defined as, let's say, public string, and I'm going to call it as maximum heart rate. Let's say we took an example earlier also, but let's say I'm going to define it something like this: maximum heart rate. So this is going to be my field. Okay, this is going to be a field, and I've not defined this in any package. The package is the default package currently. So what am I going to do? I've defined the field. I've defined the main method. Now, within this main method, what am I going to do? I can also define a method known as public integer get max heart rate. Okay, I'm going to define something like this: get max heart rate. So I'm going to create a result. Initially, the heart rate is going to be 0. Finally, I'm going to return the result. Okay. Now, so I'm going to do certain calculations here. So, what am I going to get? Let's say I'm going to pass integer age in it, and using the age, I'm going to get the max rate return. So I'll say result is equal to 220 minus age, whatever age has been given to us. So this is get max heart rate. So what am I going to do? I'm going to call this method get max heart rate, and I'm going to define the age as, let's say, 30. Okay. And I'm going to make it static. So I'm going to get max heart rate, and I'm going to print this system dot out dot print line get max heart rate defined by age 30, let's say. Okay, so I'm going to test it. So I've got a main class coded. So suppose there was a developer 1 who coded this heart monitor class. Okay, now there came a developer 2. He wanted to make a BMI machine. Okay, Suppose he want to add up some new features. So he made a new class. And let's say he said, I want to make a BMI machine. Okay. So he created a class BMI machine. Now within BMI machine, what he wanted to inherit the properties of heart monitor also, along with the other facilities of calculation of weight and other stuff. Okay.
Okay.
So in this, what he can do, he can quickly call extends. Okay.
Yes.
After calling extends, he can inherit all the methods which are available in the heart monitor class. Okay. So he extended
Yes.
all the facilities of heart monitor. Okay. Now what he can do, let's say public static void main. We can define string arguments. Now what you can do? Now since we have extended heart monitor, which means we have access to the methods available within heart monitor. Okay. So within heart
Yes.
monitor, now what we can do, we can quickly define new, let's say heart monitor. Or since we have already extended it, we can directly call the functionality also, system.out.println. And what you can do is you can quickly call the method get
heart
max heart rate. Okay. So it stays, we need to pass an age. So let's say that is 30. So now you can see that since in the class 2 BMI machine, we don't have the get max heart rate method defined, but since we have inherited the properties of heart monitor, so we can access get max heart rate method. Okay, this is the first property of inheritance. This helps us execute the program. Okay, without writing the code, we can reuse the existing code. Okay, but apart from this, there's a possibility that you can override this. Suppose you don't want to use there might be some 10 methods in your base class, but you only want to use a few of the methods from the base class, others you want to modify. Okay, so you can do that. So what we can do, we can quickly define the method public static integer get max heart rate. This is going to receive an integer age, and what am I going to do? I'm going to say return
over
230 minus age, like that. Okay, so I've defined it. So now earlier I was calculating with 220 minus 8, so I got the response 190. Okay.
Yes.
Now if I run it and I call it, so I will get 200, which means instead of the previous method, this method has been executed. So for the better clarity, I will also define a statement method executed from subclass. Okay. Similarly, I want to define it in the heart monitor also, and I'll say that method executed from the base class. Okay.
So we won't write override in that subclass.
Since we are in the same project, we can do that, but it is always advised that you can also write override functionality. Okay. You can override the code. Is that clear? So must override implement a super type method. Not a problem. So in general, we define it when it comes to, let's say, interfaces and modification of that. But others, sometimes you don't need it also, as in when you're extending the code. But if you're using it from the interfaces, then you override.
Okay.
Okay. So I'm going to run now. So currently, since I have modified the method, so you can see that this method currently executed from the subclass. Okay.
Yes.
But if I comment it out and if I save it and run it, this time it will be executed from the base class.
Base class.
I believe this is clear.
Yes.
So that's how we can quickly define the concepts of inheritance. Okay. Now, once we are done with that, so there are various examples which you can implement, but I think you're clear with the hierarchical stuff. So what next we do have is, we do have the concepts of multiple inheritance in Java using the concepts of interfaces. Okay. With interfaces, we can give a field that we can perform multiple inheritance. We can inherit the properties from different interfaces. Now, so what is the significance of multiple inheritance? So one significant difference between classes and interfaces is that classes can have fields, whereas interfaces cannot. So in the classes, we have defined the static fields which are directly accessible. But in the interfaces, we don't have the fields available. You only have methods in the interfaces. Is that clear?
Yes.
In addition, you can instantiate a class to create an object, which you cannot do with interfaces. So which means in the interfaces, we don't have constructors also. You cannot construct an interface. You can only inherit the methods from the interfaces. Is that clear? We don't have the facility of constructors in the interface, so we cannot construct it. We cannot initialize an interface. That is not available. Okay, which means you cannot create an object of an interface. You do need to implement the interface, and all the methods of the interfaces will be accessible within your subclass, but you cannot you can implement it, but you cannot inherit it. Okay, so we don't have the constructor to initialize the variables and all that stuff. Now, so you already understand what is an object. So an object stores its states in fields which are defined in classes. One reason why the Java programming language does not permit you to extend more than one class is to avoid the issues of multiple inheritance of state, which is the ability to inherit fields from multiple classes. Okay, so that due to this is one general reason due to which we cannot extend more than one class. Okay, so why we cannot extend more than one class? To avoid the issues of multiple inheritance of state. And with the multiple inheritance of state, what it is the ability to inherit the fields from the multiple classes. Okay, so there might be multiple fields defined in different classes, and then it may cause the state issues. So that's why extension is not allowed. Multiple inheritance is allowed using the concept of interfaces where we don't have the fields available. Okay, so once there is no field available, then there might not be any multiple inheritance of the states. Is that clear?
Yes.
For example, suppose that you are able to define a new class that extends multiple classes. When you create an object by instantiating that class, that object will inherit fields from all of the classes superclasses. So what if methods or constructors from different superclasses instantiate the same field? Which means, let's say if you have two base classes and both the base classes might have the same variables, so then it's going to become a problem, because it will be very difficult for the constructor to identify whose class object should be taken as a precedence, as in which should be accessed. So it's always going to be a confusion of the states. So that's why extending multiple classes or extending a base class is not allowed. Extending multiple base classes are not allowed. Okay, but you can implement multiple interfaces which does not have the fields and does not have the constructors. So there is no issue of the multiple inheritance of states. Is that clear?
Yes.
So interfaces do not contain any fields. You don't have to worry about these problems. So that results from multiple inheritance of the state. can be used with the implementation facility through the interfaces and not with the extension facility of the base classes. Okay. Coming
Yes.
to the next part. Multiple inheritance of implementation is the ability to inherit method definitions from multiple classes. Problems arise with this type of multiple inheritance, such as name conflicts and ambiguity. Okay. When compilers of programming languages that support this type of multiple inheritance encounter superclasses that contain methods with the same name, they sometimes cannot determine which member or method to access or invoke. In addition, a programmer can unwillingly or unwittingly introduce a name conflict by adding a new method to a superclass. So default methods introduce one form of multiple inheritance of the implementation. A class can implement more than one interface, okay, which means that multiple inheritance facility, which can contain default methods that have the same name. So multiple interfaces can have the methods with the same names, so that you can do. So the Java compiler provides some rules to determine which default method a particular class uses, depending on the precedence with which you have defined. Now, Java programming language supports multiple inheritance of type, which is the ability of a class to implement more than one interface. An object can have multiple types, the type of its own class, and the type of all the interfaces that the class implements. So this means that if a variable is declared to be the type of an interface, then its value can reference any object that is instantiated from any class that implements the interface. Okay. So I believe this is clear. So using interface is a type, as in where you can, when you are using elements, so instead of that, you can use it as a type value. Okay. So with the multiple inheritance of implementation, a class can inherit different implementations of a method in the interfaces that it extends. So the compiler uses with respect to the precedence order, which one to use. Okay. So that's how multiple inheritance is implemented. So I believe you understand the concept of what is extending a class and what is the meaning of inheritance, multiple inheritance with interfaces. So with interfaces, we don't have the fields, we don't have the constructors, but in the base class, which we are extending, does have the fields and the constructor. We can initialize the constructors or call the constructors, and we can access the fields directly. Okay. Rest in the next session, we'll get to see about overriding and hiding, polymorphism, and the other important concepts of inheritance. Okay, is that clear?